Hello guys, this is Shirub from Mathematica. Today I will be discussing a question from CSIR NET 2023, December 2023, question number 30 and question ID 704065. And this question is from linear algebra and this question is from part C. So it has 4.75 marks and we have to check each and every option individually. So given a quadratic form Q of x, y, z, which is x square plus xy plus y square plus xz plus yz plus z square. So first option is given that there exists a non-zero vector u from q cross q cross q or q cube such that q of u equals 0. So let's take that suppose u is vector x, y, z such that q of u equals 0. So what we have is x square plus y square plus z square plus xy plus yz plus zx equals 0 by given, this is given by given condition. So if we multiply both sides by 2, we will have that x square plus 2xy plus y square, again y square plus 2yz plus z square plus z square plus 2zx plus x square equals 0, and we will get x plus y square plus y plus z square plus z plus x square equals 0. So since the vector u, this is from x, y, z, which is x, y, z, and x, y, z individually comes from q, that means all are the rational. So and it satisfies this identity, sum of all squares. Since x plus y square is positive term, y plus z square, so it's called non-negative term, and z plus x square is also greater than equals 0. So and sum of all of this equals 0. So what we have remaining is x plus y is 0, y plus z is 0, and z plus x is 0. So this implies that x equal to minus y, and this implies y equal to minus z, and this implies z equal to minus x. If we take all of this and equal all of this, we will get that x, y, z all are 0. So if we check this, so x equal to minus y and we have y equal to minus z, so what we have, minus of minus z equals z, and z equal to minus x, this equals minus x, so x equals minus x, so this implies that 2x will be 0, and this implies x equal to 0, so this implies y equal to 0, and since y equal to 0, so z equals to 0. So x, y, z is all are 0. So this come so if x, y, z comes from the rational, even if x, y, z all are real numbers, then also this identity will be true. So if x, y, z coming from the real number and this identity holds, so this also implies that x, y, z all are zeros. So we can't find a non-zero vector u coming from r cross r cross r or r cube such that q of u equals 0. So we have to discard first two options. Next we have to verify, given that there exists a non-zero vector u coming from c cross c cross c or c cube such that q of u equals 0. What we have that identity, so given here is the vector u where x, y, z coming from c cube, where x y z belongs to C, and we have that identity x plus y square plus y plus z square and z plus x square equals 0, and x y z all are the complex number. We have that identity in complex that 1 plus omega square is 0, where omega square are, this is, if this is omega, this is omega square. Omega and omega square are minus half plus I root 3 by 2, and omega square is minus half minus I into root 3 by 2. So 1 plus omega square is 0. So if we equal this, that means if we take x plus y equals 1, y plus z equals root omega, and z plus x equal omega. So if we take this system of equation and solve this, let us solve this. So let me remove this. If we solve this, this is 1, this is 2, and this is 3. So let's take 2 minus 3. What we have, 2 minus 3 if we take, so y minus x will get, for y minus we will get root omega minus omega, and we previously have y plus x equal 1. So if we take sum of 2, we will get y is 1 plus root omega minus omega by 2, and if we equal this, and from this we will get x equal to 1 minus y. Sorry, let me erase this. One minus y. So from this I am getting, so we have 1 minus 1 plus root omega minus omega by 2. This implies 2 minus 1 minus root omega plus omega by 2 minus plus 1 minus root omega plus omega by 2. We will have x, and for z, to calculate the z, we will take this so we have x plus z equals omega, so z equals omega minus x, so omega minus 1 minus root omega plus omega by 2. This equals 2 omega minus 1 plus root omega minus omega by 2. So this equals minus 1 plus omega plus root omega by 2. So we will get a non-zero vector u, which is x, y, z, where x is, let me see this, 1 minus root omega, 1 minus root omega plus omega by 2, and we have y equals 1 plus root omega, 1 plus root omega minus omega by 2, and we have z is minus 1 plus omega plus root omega by 2, which is non-zero vector. 0 here, 0 represents 0 0 0 coming from C cross C, which is a non-zero vector, and it satisfies q of u equals 0. So option 3 is true. So there exists a non-zero vector u coming from C cross C such that q of u equals 0. So we have to check option 4. The real symmetric matrix 3 cross 3 associated with satisfies that quadratic form is invertible. So what we given a quadratic form, so q of q of that vector xyz, which is given that x square plus y square plus z square plus xy plus yz plus zx. So if we take the associated vector with this associated matrix, so we know how to find this. So we have the coefficient of x square, y square and z square. We will take this in diagonal, and we have coefficient of xy is 1, so we will take half and half for xy position, and for zx position we have same coefficient 1, so we will take half and half, and for yz position we have same coefficient. So the matrix we have A is 1 half 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 1 half and half half 1. We just need to check that A is invertible or not. So it is easy to check now. So let's take the determinant of A. So determinant of A is given by 1 into 1 minus 1 by 4 minus half into half minus 1 by 4 and plus half into 1 by 4 minus half. So we have 3 by 4 minus half into 1 by 2 minus 1 by 4. If we take the negative sign, we will get minus half to 1 by 2 minus 1 by 4. So we have this 3 by 4 minus, we have half and half, so we will get 1 by 2 minus 1 by 4, which is 3 by 4 minus 1 by 2 plus 1 by 4. So 3 by 4 plus 1 by 4, we have 1 minus 1 by 2 is 1 by 2, which is non-zero. So A is invertible. So option 4 is true. So you will get 4.75 marks very easily. So thank you guys for your time, and if you guys like this video, please don't forget to hit the like and subscribe button for our YouTube channel Expert Mathematica. And recently we have a news that CSIR NET June session 2024 is postponed, and it is postponed but it is not cancelled. So you guys please don't get disappointed. Please be prepared for CSIR NET June 2024, because that exam will happen anytime. And thank you guys. Thank you for your time.